चल
You know about how bubble will form. Normal. So bubble form. Which phenomenon it is acting about. You know about surface tension. Like see the bubble. So in this bubble, it has a inner surface and it has a outer surface. Surface tension acts in outer surface tension. Right. So in this bubble,
ऊपर रखिए
one is inner surface and another one is outer surface. So I will need to study electric bubbles. Why? That will I know it.
टिकट का था ए
Bubble like this. This is a half bubble. You know the mechanical force acting on a charge sheet. Mechanical force experienced by unit area of charge conductor. You know, you already wrote in your notebook. Just open that. So the mechanical force acting pressure is force per unit area. So what is the expression for pressure? Sigma square by 2 epsilon. So after that we will study this electric subbubbles. Okay. Then you know, then write. One thing write. We proved in mechanics. We proved in mechanics that the excess pressure we proved in mechanics that the excess pressure on a soft bubble of radius r small r on a soft bubble of radius r due to surface tension T
सरफेस टेंशन की
surface tension T is given by, you know, in mechanics tension in a surface tension in a soft bubble E equal to how much? No, mechanics. No, 40 by R. How? You know this in mechanics? How it's from T is tension, surface tension. R is radius of soft bubble. Then P is pressure. So how it will become? It is in you are in 11th class. Okay, I will tell you. You know the external force acting outward, external force, and there is two tension acting on this surface. One is outer surface, another one is inner surface. So tension acting is with two tension because outer surface one tension and the force is acting outward this way. So now what is force? You know, pressure per unit area. Then tension you know. So pressure here, pressure upon area. How much area? This is a circle, outer circle, outer force, pi r square. And this is tension. Tension acting first surface and tension acting second surface, means inner surface. So tension is how much? 2 pi r. And this tension also 2 pi r. So you know F equal this force equal to this tension. So V by pressure. This tension is equal to this one. Okay. So here T and
Pressure is equal to force by area. So how force pressure by area?
so if pressure is here pressure equal to force upon area. So that's why I am confused. Force upon unit area. Okay. Then how force? What is force? Pressure into area. So P into A. A means I. So here force is equal to this two tension. You know, outer force is equal to this tension. So F equal to 2T. Okay. Then F is P into IR square equal to T into T, not 2T, T into T, T square, T into T. So 4, 2 pi r into 2 pi r. 4 pi pi square r square. So here pi cancel. This is in 11th class. I don't know. This is not in our book also. Just this is the expression. From this, the equation is coming. Okay. Tension is pi r to pi r. Okay. 4 pi r. 2t. 4 pi r. Tension is 2t, not t square. 2t means 2 pi r plus 2 pi r. 4 pi r. So r cancel. Okay. Then p equal to pi cancel. P equal to 4 by r. And t is also here 4 by r. 2t. Just check this one. I confirm later because this one is 11 plus. I also forget this. But the expression is like this: outward force and equal to this tension. So P into 4T by R, like this. Pressure in a soap bottle. Okay. Right. This type expression just considering how strong. Like this.
Go ahead.
So the expression for pressure is P equal to 4 P by R. Then write surface tension T is given by this one. Okay. Then you write if the bubble is now given a charge Q. If a bubble is now given a charge Q, then the outward mechanical pressure, outward, you know the expression for outward, this is inward. So what is the expression for outward pressure? You got mechanical force exerted by unit area of charge conductor, P equal to sigma square by 2 epsilon. Sigma square by 2 this much. Then what is sigma? Charge density. So charge upon unit area. A or S, whatever you write. Then Q by S equal to Q by area. Here area in a sphere. Surface area is 4 R square. So put this value in this equation. So here sigma 1 by 2 pi epsilon. Then the value of sigma will U square by 2 square by 16 I square R4. Okay. Then 2 square by here 32 pi square R4. This one. So you know, write it this one. All right. So you know about how the bubble when we just like form a bubble, how it is large, small to large, how it happens. That excess pressure, just when we just like this, the excess pressure to our cheek.
Correct, good, देखिए दे.
The excess pressure. So
Time to the.
excess pressure you know like this. If the soft bubble like this, then the excess pressure will increases to this much. Okay, the soft bubble will expand. So right. So we need to calculate the excess pressure, and when we apply a charge in a electric soft bubble, what will happen? That is our topic. So write excess of pressure. So this is initial pressure and this is final pressure, inward and outward. So write only P. Excess pressure P equal to initial minus final. Then write 4T by R. 4T by R. This one. P equal to P inward minus P outward. Why P inward and P outward? Why P outward minus P inward? inward and outer, because inward pressure is high. When we like this, the outer pressure is small and the inward pressure is high. That's why we like this. So inward pressure, put inward pressure 4T by R minus Q square by 32 pi square epsilon naught R. Just calculate. So 4T 4 by R, common. Then here T minus, just outside this, Q square by how much? 4 by R common. Then T minus Q square by, no, here 32. It's just outside the 4. Then what is the value here? If we multiply these two things, then 4 and 120 will be cancelled, then we get 32. So 128, then write this one, 128 pi square epsilon naught, and R is, we take common R, then R cube. This is the expression for excess pressure.
कैसे फर्क नहीं दिखा यार, मैंने आया और हार गई।
You want to see an exact experiment? Yes. Just for 5 minutes.
Yes. धराने यार ए कैमरा की आनार देखा ठीपी मार बोतल रो ठीपी कर बटल रो ठीपी कर मार बोतल रो खोल थी
थोड़ा शाम को डाल दें
अभी पानी
ये पानी का बोतल ला उधर से मग आला
हाँ अब चल रहा है
with hands. You have to hold it.
नहीं मैं हिलेगा तो फोन स्मॉल
You hold this. Small finger.
धीरे से पकड़
Oh, it's like this. But why the bubble is crossed? Why? Because the
outside pressure.
this much pressure didn't hold that bubble. Okay, but
pen again, pen.
pressure is here. See here. Like this. Okay. See this. Then I just
Visible.
insert this one to this bubble. Okay. After some time, what will be done? After some time,
Size will decrease.
size will decrease or increase.
Decrease.
How?
एयर प्रेशर मार
Because
अंदर का जो हवा है
because pressure outward, coming outward. Inside pressure is excess. We calculated here. But when we put this that straw, then the pressure is going outward. So this will decreases. But here we study electric soap bubble. When we insert a charge inside the soap bubble, what will be the bubble will form? The bubble expand. That is the concept. When we apply the pressure exerted outward, so the bubble is like shrink, like decreases. The bubble will decreases. So that the radius will small. But when we insert a charge, electric charge inside a soap bubble, the radius is increases and the bubble is expands. That is the purpose. If we just
छोड़े
ले लो कौन अभी
like this.
क्या पड़ेगा
Okay.
later 1 minute one experiment it
Because this is a pressure, then will come like this. Okay. Come to our
रखो
does the charging
Bro, your experiment.
Abhishek sir
So another experiment. For that.
because we need that excess pressure. If we insert a small charge Q inside the bubble will expand. That is the purpose of experiment. Okay. Then right. Thus the charging of soap bubble. Thus the charging of soap bubble. The effective value of its surface tension decreases from T to T minus this one. T to 4 and 4 by R is common. So how much decrease in normal case? T to Q by this much. Okay. Right. Then surface tension decreases from T to T minus Q square by 128 pi square epsilon naught R cube.
क्या
This one. T to Q square by and due to this the size of the bubble increases. Then we calculate how much radius will increase when you insert a charge inside a bubble. How much radius will increase? That is our purpose. But when with a normal soap bubble, when we just put anything, then the radius is decreases and the pressure is going to outward. So the bubble is like thin and like small. Then, but when we insert a electric charge inside the subbubble, the radius will increases and the subbubble will decrease. Subbubble expand. Then right. So increase in radius of bubble. We have to calculate this one. Then right. Since in the bubble the temperature remains constant. So when we do the experiment, when we just insert a charge inside the bubble, the temperature is constant.
In the bubble?
Okay, I'll repeat it. Since the bubble temperature remains constant, since the bubble temperature remains constant, temperature is constant here. So what is Boyle's law? What is Boyle's law? Boyle's law, Charles' law. What is Boyle's law?
Pressure is inversely proportional.
But how it is coming? This theory how we know ideal gas equation is equal to nRT. So here temperature is constant and R is universal gas constant, you know. Then number of moles here stands. Then this is all total constant. So P is constant or P inversely proportional to. Okay, you know this, then right. So apply Boyle's law. P inversely proportional to P. Here we know how much volume of this sphere. You know volume 4 pi r cube. Right. So here V inversely proportional to 1 by V equal to 4 pi r cube. So V directly proportional to r cube. 4 by 3 pi r cube. Then you know pi r cube directly proportional to V equal to directly proportional to r cube. So pressure inversely proportional to r cube. Then right here P equal to some constant K into r to the power minus P. You can write this. P equal to K into r to the power minus P. All are getting?
Yes, sir.
Now, differentiating both sides, right? Differentiating both sides with respect to small dr, right? Differentiating both sides with respect to differentiating both sides with respect to small dr. Differentiating. So, GT by dr, here R equal to into R minus
D by dr of
minus K into R
into r to the power minus 4. K into minus K into 3 r to the power minus 3 into r to the power minus 1. We can write it this way. R to the power minus 3 into r to the power. So we know here K into r to the power minus 3 equal to how much? T. T equal to
K.
K into r to the power minus 3. So how we write?
3 P R is
Minus here. Minus 3 P by r. R minus 2. Here r minus 1. Then we have to calculate what is radius. We have to calculate the radius. So what is dr here? Write the dr. Dr equal to
P P R by minus
r by 3p into this one minus here. In this equation 1, okay? Equation 1. dr equal to minus r into dp by p. Alright. Just cross multiply. Dr r by dp into this. So we know decrease in pressure. What is decrease in pressure? Decrease in pressure. Okay, write like this. dp equal to plus write root 2 square by 32 just I square epsilon naught r 4. Do this and the decrease pressure is minus decrease, so minus coming here. We know this. All are getting? Then apply the value of dp in this equation. So this is equation 2. So putting equation 2 in 1. Here. What is the value? Minus minus also cancel. So what is the expression? 2 square by 96 pi square epsilon naught then P r into T. Just rewrite this one, okay? Rewrite it. 1 by 26 pi square epsilon naught into 2 square by E R Q. This is our expression for radius. Okay. So, all are writing this one? Then write. This is the expression for the increase of radius. This is the expression for the increase of radius for this also. All are because then write it. Two soft bubbles are problem. Two soft bubbles are two. Two soft bubbles are blown. Two soft bubbles are blown. In first bubble, excess pressure is 4 times. In first bubble, excess pressure is 4 times. 4 times. That of second bubble.
What times?
In first bubble, excess pressure is 4 times that of second bubble.
Lack of.
That of second bubble. The ratio of 4 times that of second bubble. The ratio of the radius of the ratio of the radius of first 10 seconds of bubble. First 10 second bubble is 10%. The ratio of first 10 seconds of bubble is we have to calculate the radius up to first 10 second bubble. We know the expression for radius. So P equal to 4 T by R. You know this one. So in first case, first bubble. So in first bubble, right? In first bubble, P equal to 4 T by radius is R1 in first and second equal to 4T by R2. Okay, and pressure is also T1 and like this one. So we have to calculate the radius, ratio of radius. Just to divide the equation 1 and equation 2. So, equation 1 divided by equation 2. Okay. I wrote directly. Okay. Here. R2 by R1 equal to 4 by 1. 1 by 4. R2 by R1 equal to then R1 by R2. R2 by R1 equal to 4 by 1. Here. All are getting.